Good morning, students. Today we are going to discuss the topic friction, and it is under the chapter 5 laws of motion. Now all of you know what is friction. Let me read out what we have written here. Friction is an opposing force that comes into play whenever a body moves or tends to move over the surface of another body. Now you see, if you see a surface very closely, you will see that the surface seems to be smooth. But if you observe the surface by using some instrument, then you will see that there are lots of irregularities on the surface. Now basically friction occurs due to these irregularities. Now when you place an object over the surface, what happens? There will be some interlocking between the irregularities, because the surface itself has irregularities, and if we place the object, then the surface of the object also have some irregularities. Now when you place the object on the surface, what happens? Interlocking of irregularities occur, and as a result the friction arises. Now here we have used two diagrams. Now an object is on the surface. The surface has irregularities, and when you place the object on the surface, the irregularities of the object interlock with the irregularities of the surface. Now if you want to move the object over the surface, what happens? You have to give some force. Now the frictional force basically acts opposite to the direction of motion, or you can say opposite to the direction of the applied force, or you can say it is some kind of resistive force which opposes the motion. Now regarding laws, there are certain laws put forward related with the friction. Now what this law explains basically, suppose you see this is your surface and we have placed an object. That shaded part is your object. Now what happened? The weight acts downward as we have specified by W. Now from Newton's third law, every action has an equal and opposite reaction. So what happened? The action is the weight, so definitely some reaction force acts on the object which balances the weight. Now if the weight is more, what happens? Reaction will also be more as per the Newton's third law. Now if the weight is more, what happens? There will be strong interlocking of the irregularities between the two surfaces. Now when the interlocking between the irregularities is very strong, what happens? You have to apply a huge amount of force to move the object. So you can say definitely the frictional force is also high, and the interlocking will be high, and the interlocking will be high when the weight of the object will be more, and weight of the object will be more means the reaction is also more. So from this you can say that force of friction is directly proportional to the normal reaction, because if the reaction is high, weight will be high, and if the weight will be high, then interlocking will be firm, and if the interlocking is firm, then you have to apply high amount of force to move the object, and the requirement of the high amount of force means what? Your force of friction will be high. So that's why force of friction proportional to normal reaction. So F proportional to I. That small f we have defined here, force of friction. Now if you want to bring one equal sign, what you have to do? You have to bring one constant of proportionality. That's your mu. F equal to mu r, where mu is the coefficient of friction. And definitely in equilibrium R equal to mg, it balances. Action and reaction are equal and opposite as per the Newton's third law. So the law of friction is F equal to mu r, and you can say that force of friction is directly proportional to the normal reaction. This is the law of friction. So we are going to use this expression number 1 as well as number 2 in our further extended topic. Now next topic which we are going to discuss is your angle of friction. Now you see again, let me place the object, so weight is vertically downward and reaction will be upward. And if you want to move the object from left to right, then definitely you have to apply force from left to right, and obviously the force of friction is from right to left. Now angle of friction is nothing but the angle made by the force of friction and the you see the angle of friction is nothing but the angle made by the resultant of the force of friction and normal reaction with the normal reaction. Let me to repeat once again. Angle of friction is nothing but the angle made by the resultant of the force of friction and normal reaction with the normal reaction. Now what is the resultant of the force of friction and normal reaction here? That is nothing but the diagonal. So the diagonal makes an angle theta with the normal reaction. So theta is the angle of friction. Now if you have to define tan theta, you have to consider perpendicular by base. So if the magnitude part, consider f by r. Tan theta equal to f by r, or theta equal to tan inverse of f by r. So let me to repeat once again. Angle of friction is the angle made by the resultant of the force of friction and normal reaction with the normal reaction. So here the resultant is the diagonal, and it makes an angle theta with the normal reaction. So tan theta is nothing but is your perpendicular by base. We are considering the magnitude, that is your f by r, or theta equal to tan inverse of f by r. And also from the law of friction, mu equal to f by r, as per here, mu equal to f by r. So from 1 and 2 you can say tan theta equal to mu. So you can say that tangent of the angle of friction is nothing but the coefficient of friction. Now next we are trying to define angle of repose. Now initially you see if alpha equal to 0, then this diagram and this diagram is identical, or this diagram and this diagram is identical if alpha equal to 0. So what we are trying to do here, we are placing an object on the horizontal surface like this, and slightly we are trying to pull the line up, making an angle alpha. Now you will see, if we raise the level by any angle other than alpha or less than alpha, the object does not slide. But if you make the inclination alpha, then object is at the verge of sliding. So angle of repose is nothing but the angle made by the inclined plane at the verge of which the object tends to slide. Let me repeat once again. Angle of repose is the angle made by the inclined plane with the horizontal, such that the object placed on the inclined plane is at the verge of sliding. So you see the weight always acts vertically downward and reaction is normal to the surface. So R is normal to the surface and weight acts vertically downward. So if alpha equal to 0, then the R and mg is along the same line but in opposite direction like this, and the diagram will be like this if alpha equal to 0. So that's why if alpha is the angle made by the inclined plane, then alpha is the angle made by the weight with the opposite arrow of the normal reaction. So it has component mg cos alpha and mg sin alpha. Now if it is at the verge of sliding, then small f equal to mg sin alpha and r equal to mg cos alpha. So f equal to mg sin alpha if the object is at the verge of sliding, and r equal to mg cos alpha. Now if you again simplify f by r, mg sin alpha by mg cos alpha, so mg goes off tan alpha. And also from the law of friction, f by r equal to mu, so you can say mu equal to tan alpha. So you can say that tangent of the angle of repose is equal to the coefficient of friction. So here also we have got tangent of the angle of friction is equal to the coefficient of friction. So from here you can conclude that mu equal to tan alpha equal to tan theta. So you can say alpha equal to theta. So alpha is the angle of repose and theta is the angle of friction. So you can say angle of repose is equal to the angle of friction. So please go through this part, and in physics basically less mark is allotted for the statement, rather mark is allotted for the expression. So everything is in the reference book or in any textbook or in CBSE textbook. Please go through and try to find out your doubts, and we'll try to sort it out. So this is all about. Thank you.